be like taken out to the woodshed and turned into glue. What's up, Aduki? Good to see you. Oh, now we're working. Nice. All right, here we go. Welcome. To get help with your homework, just join our Discord. And submit a question. All right, what's up, Sensation? Good to see you, dude.
How's it going?
Toast.
How's it going?
Toast. Yes, it's going great. Thank you. Did you just wake up as well?
I can never tell if you can hear me.
Oh, I can hear you. Oh, I can hear you. You're good.
Yeah, not long.
Not long ago, he says. Not long. Let me pop up the chat here. There we go. Yeah, what's up? What's happening in the world? Is World War III about to start? I heard that the U.S. is now allowing Ukraine to like use long-range missiles on Russia. Uh-oh.
Wasn't that a thing anyway?
Uh-oh. You think Russia's going to do anything? I don't know. I'm too old to get drafted. That's all on you guys. That sucks. I'm sorry. No.
You're not too old to get drafted.
I think I am. I'm 35, right?
Not in a world war.
Yeah, not in where like most of the draftable population, I don't know, has anxiety and is on antidepressants, I guess.
I think the only people that didn't get drafted during the last World War were those that were actually old.
Actually old. What is actually old?
Retirees.
Well, let's look. Well, I feel like I could retire. You know,
and even then they had a job here. They were called Dad's Army.
Dad's Army. That sounds kind of fun.
They basically they defended this country here, so they were still drafted. They were just not sent overseas.
Yeah, black out that. I don't like this thing. Why is this thing making? There you go. Go away, line. Okay, cool. There we go. Let's see. What is the draftable age in the United States? Hate to be Mr. Doom and Gloom today, but 18 to 25. Yeah, see, I'm fine, dog. Yeah, I think we're okay. But, okay. Wait, including transgender people who were assigned male gender at birth. Oh, that's interesting. So you don't get out of it just for saying you're a woman. Ah. Including people with disabilities? That kind of makes it. I mean, why would we have people with disabilities in the Army? That doesn't sound like a good idea. I don't know.
And they drafted me.
Oh, yeah. Anyways, you know, this is why it's a good idea to get an education, guys. Yeah, I mean, this is what I'm talking about. This is what's on the news. Because if you are smart and you're good with computers and like, I don't know, you can do math and stuff, they're probably not going to have you on the front lines. They're probably going to want you to be doing some cool stuff like with hacking or flying drones or stuff. So go get that education.
Which was on the front line 20 years ago.
It was. It was on the front lines 20 years ago. Not anymore these days. You get to sit in a nice comfy couch and just, you know, bomb people with a RC remote. Anyways. Anything else new that happened in the last 24 hours? Let me see. We got any news in the server? We got a lot of great questions in weird languages I've never seen before. That's fun. Nice. Okay, fun. When am I streaming? I'm streaming right now. You're good.
I told you. Like, what?
Also, apparently Cristiano is an alt of Diba, and like, no. You can't run alt accounts. People try to speed run like the tier 1 like multiple times. Don't do it. No. It's not the point. Drafting.
Wait, did you actually confirm it? Sorry, did you actually confirm that in the end?
I didn't confirm that, but one of his friends said it was him. So like until he proves otherwise, I'm gonna assume his friend is correct. The way I get them to the prove otherwise is I have both of them sign on at the same time and they both have to speak. Asner did, yeah. Asner outed him. Yeah, good job, Asner. I kind of had a suspicion. Well, I can never. I'm here for that. But if it's the same person just rerunning it, like, dog, don't do that, man. That's just yeah. Just cheating yourself. Drafting is not only front lines, but also some base, more useful than just brute force labor, you know, in the trenches. Good. It's a good look for yourself. Okay. Anyways, okay. Enough about the impending doom of World War III. Let's start off the stream. Welcome everyone to Actual Education Office Hours. My name is Dr. Gold. This is a stream that helps you out with math, homework, science, homework, all sorts of fun stuff. I'm trying to remember who I did. Oh yeah, this was. Oh, I gotta turn off this stream mode. Simio. This was Simio. Simio, I think, was French. Is this French? Calculez. Calcule. Calcule.
Calcule.
Calcule. I know. See, this in Italian means like if, right? So maybe it's the same thing in French. I don't know. We learn all sorts of cool languages. Okay. Let's see. I think let's try to understand what this language is. Okay, this is a fun one. I believe they said French. Cool. Thanks, Yash. Zadachik is. Oh, dude, I can't. Once we start putting all these Z's and like E's next to each other, I don't know how to pronounce this. You know what?
Is it Hungarian?
Is this Hungarian? It's kind of like or Turkish maybe. Is this Turkish?
It's not Turkish.
Okay. Oh, that Asner says that is Hungarian. Very cool. This is your question, Asner, right? What does this mean? I love learning new languages. I think it's super fun. I'm gonna guess that this means derive the function. Deriva siju funksish. But what is this? Uzra kunach. Oh, it's Bosnian. Oh yeah, all you guys are Bosnian. That's right. We got a lot of fun like Bosnian people here in the server. Calculate the derivative of the function. Awesome. I love that. Okay, Asner, this is actually a really good one. So they want to know what is df dx is equal to what if f of x is equal to x cubed sine of 2x. This is actually a really fun one because it's a little complicated. It involves a couple rules, okay? Do you know how to do this one? It involves a product rule and a power rule and a chain rule. Okay, cool. All right, so I'm going to teach this to you. So I always like to look at functions from like the big picture is what I'm going to say, all right? And so what I notice is that I have something here in green multiplying by something here in fuck it. Let's start the Christmas colors. I know it's not past Thanksgiving yet, but I'm feeling fucking merry today, dude. All right, here we go. All right. Something times the red. All right. Key thing being here, right, that the things underneath these blocks both have stuff that's in terms of x. Whenever you have things in terms of x, that means you have to kind of treat them as like blocks. And so if they're multiplying by each other, they have special rules for derivatives. If, for instance, what was beneath this block was just a number, let's say, I don't know, let's say this number was like 42, then you don't need to worry about it. You can just pull that out and just do the derivative of this thing by itself. The Italian flag, yes, I guess it is the Italian flag. Oh, nice. I mean, I am Italian, so I guess that works out.
Nice.
That's pretty fun. Okay. Is this the Italian flag? Is it green, white, red, or is it red, white, green? Yeah, right?
I can't remember.
I think Mexico is this one, right? Oh, one second. Now I'm curious. Yeah, Mexico is green, white, red. Oh, and
Spaghetti alla tacos.
And so is Italy. Okay. All right, so it could be the Italian or the Mexican, apparently. Okay, anyways. All right, so here's the rule. Anytime, let's call this thing A and let's call this thing B. Anytime you have A times B and you're trying to take the derivative of that thing, that's what this ddx means, take the derivative of it. That's always going to equal the derivative of the first thing, so that's called A prime. We write this prime thing here to say take the first derivative, times the second thing, plus the derivative of the second thing times the first. Have you seen this before, Ashner? This is called the product rule. And it's how we take derivatives of things when we got two big chunks and they have x's in them and they're multiplying by each other. It's kind of the hardest thing in calculus is just noticing what the big picture is. Gee, Dr. Goal, sir, can you prove that using the definition of a derivative? Oh, I wonder. Yo, what's up, Obi? Nice, dude.
Nice.
Yeah, big shout out to Obi. Love you, Obi, dude.
What
Obi,
does it
did we
mean
figure
from
out
first principles?
I think I could probably do it from Like the limit definition? Is that what you're saying, dog? Shout out to Obi. Yeah, nice. Obi's cool. We like Obi.
Welcome in.
Welcome, Obi. Oh, you want me to do it for... Yeah, I probably could do it from the limit definition of a derivative. We can do that afterwards. You know what I find I like to do? Students really, in order to... Actually, I wrote about this. I wrote about this in my... One sec. I wrote about this in my... I had to write a 1-page long statement of teaching philosophy. Did you have to do this, Obi, when you applied for like your teaching position stuff? Did you have to do this? Yeah, go give Obi a follow. Yeah, right? Okay, so I did this recently. I had to write a, first of all, I had to do some, like, bullshit, equity, diversity, inclusion statement. But luckily, you guys make it easy for me to write about that. That was nice. But the other thing I did was my teaching philosophy statement. So I wrote down kind of some, I guess, a manifesto about how I like to teach. I think that's what this is for. I've never applied to a lecturer position before, so I kind of asked ChatGPT and fed it some examples. I'm like, does this look good? And it's like, yeah, sure. But anyways, the thing I talk about is when you're showing something new to a student, I think you want to balance procedural fluency, conceptual understanding, and practical application. That to me are like the 3 steps of learning. And so procedural fluency is just a big fancy word for like, how the fuck do I do this? And I feel like that's the best way to get a student interested, is to bring them in and be like, hey, so that's what I say. I begin by using procedural techniques or tricks that directly address common misunderstandings when solving homework problems. So most of the time, students just want to get their homework done. And so I think the best way to like get them in is to be like, hey, here's the trick you're looking for to do your homework. And then once they have that, they feel probably a lot more confident that they can do math, and that math isn't this big scary thing that's like trying to kill them and like they don't understand. And then I feel like you can start saying like, okay, see, now that you can do that and now that you're confident, let's maybe do what Jeff says and like learn about why this works. And this is where we could show you the limit definition of a derivative using being able to prove the product rule. That's cool. And then the last thing past that I say to cement their understanding is to do a practical real world application. And at that point, if they see that, it looks good. Next, the tricks. Let me see this. What the fuck is this, dude? Nix the tricks. What is this? Oh. Explains why tricks are so bad for understanding math. Oh, okay. Too funny. So this is against what I say. Okay, I need to look at this. Obi, you have a lot of really cool books on education. I need to get. I put that one on my wish list. The other one you showed me, the really long one. I really like that. But this is another cool one. Here, I'm gonna add this to my wish list. Let me see. How do I add this to the wish list? Because this is cool. Oh, I need to sign in. Ugh, whatever. I'll get to it eventually.
Why is Zach's picture Zeno-sama?
Who is that? Hey, is that Zaruto? What's up, dude? You want to come to the stage, Zach? He likes anime. He's an anime guy.
Just Zeno-sama. Nande.
Yo, what's up, dog? How's it going, brother?
It's been good. Got accepted into college.
Fuck yeah, dude! Our boy got accepted to college! You know what that means? You get a new role in my server, dude. You get into the... Where's I have this role. It's called, like, Achieved College. Yeah, there you go. Congrats. Now you have the role Achieved College. Nice. Congrats. What are you doing? What are you going to do in college? That's super dope, man.
Computer engineering.
Wow. That's a nice one.
Nice.
Big future in computer engineering. Sweet, dude. And are you a senior right now, or were you a senior last year? I forget.
Yeah.
You're a senior right now. Okay,
I'm a
cool,
senior now.
Awesome. That's dope, dude. Man, dude, congrats. You're about to start the best 4 years of your life, I say. College is a lot of fun.
Yeah.
Sick. Is it far away from home, or are you going to be pretty close, or?
It's kind of like downtown where I'm at.
Nice. That's fun. Yeah, so you're not too close. I did the same thing. My undergrad, I was in Austin, which was like 2 hours away from where I grew up. So it was like slightly far enough that my parents couldn't like surprise visit me if I was having a party or something. But not too far that I couldn't come home for the holidays easily, or like come get some dinner if I was running out of food. Happens sometimes. That's cool, man. Congrats, dude.
Yeah, even the college said that they'll give me a job for doing engineering like my senior year.
Sick, dude. Yeah, that's a very important thing about where you go to college, is making sure that you use the resources they have there to line you up with a job afterwards. Because depending on the university, some of these universities are very well tied to like an alumni network of people that work at companies, and they love to help other people from the same university come up with a job. Yeah. Maryland versus Massachusetts. Yeah, and Yashua gives some advice. Says, advice as a current second year, enjoy college. Don't load yourself with 100 different things. Yes, I agree with that 100%. Yeah, like enjoy your time. Take courses, take some good courses and stuff, but don't feel like you have to do what you were doing in high school, taking like 8 APs or something. You know, college is a very unique, special time in your life, because you're an adult, but you really don't know what's going on, but you have all this freedom, and then you also don't have that many like responsibilities. Like you don't have kids, you don't have a job, you don't have health insurance that you have to worry about. Usually that's kind of taken care of, hopefully. And then Yashua says, yeah, definitely find a club or two you really enjoy, and then worry about work over the summer. Yeah, you did. Are you doing ROTC as well? I forget.
Well, I'm at the Citadel.
Oh, sick. Oh, wait, I know where the Citadel is. That's a great engineering school, right?
Yeah, I'm going to School of Engineering there.
Oh, fuck yeah. Yeah. Wait. Citadel, one sec. I know this. Citadel, it's in North Carolina? Which one am I thinking of? South Carolina. Yeah. Oh, this is a very cool college, man. Yeah, actually, one of my friends in undergrad ended up being a professor here for, I think, the Army Corps of Engineers. Is that who's here as well? Army Corps of Engineers?
Yeah, I met an Army recruiter that said that if I do Army there, he'll help pay for my tuition.
Oh, hell yeah, dude. Sick. Yeah, no, this is a great college. Yeah, and Army Corps of Engineers is a great program, and also it's guaranteed work, right? The Army always needs more engineers to do things. Yeah, sick, man, dude. You're gonna have a great time. Because I think you're originally from Florida, right? Ish. I think like Northern or Jacksonville or something. I forget.
No, I'm originally from South Carolina.
Oh, you're originally from South Carolina. Oh, maybe that's what's his name? Raiden. I think Raiden's from Florida.
Yeah.
Or Levante, whatever his name is. Yeah. Okay, cool, man, dude. Well, that's awesome, dude. Congrats on that, man, dude. That's really cool. I love hearing that. I love hearing, because you've been in our server since 2 or 3 years ago. You've been in here a while, so I'm really proud that you made it into college, into a great college, into a great program. That's like, I don't know, that was the whole point of everything I've been doing here. So like, I'm so glad that it worked out for you. So that's dope, dude. Hell yeah. You know to always come back and ask for help. Like if your engineering classes get hard, man, or the math stuff, like we're here for you, dude. We got you, man. And it's all free.
Yeah, the other college I was probably thinking of doing was CSU.
Mm-hmm.
But I'd have to choose a church, and I haven't been to church like forever, so I didn't know what church to really choose.
You have to join a church? Wait, what? College requires you to join a church?
Yeah.
Oh my God! Wait. CSU. I guess it's a Christian church, is what it is, right?
Yeah.
Oh,
yeah,
Charleston.
So I have like pick a per church in the application.
Yeah. Oh, you know what? I love this because they call Charleston the Low Country, right? I love how they call it the Low Country. Low Country boils are my favorite type of food too, by the way. I love that stuff. I was in Savannah actually a couple months ago, so I was right down the street. Yeah. I think you'll make a good choice going to the Citadel. That's a very well respected school. They have a great engineering program. And again, the job security is like none other, because they'll really help you out. As long as you study and do well in your classes, they will make sure you have a job. It's kind of the whole point. And also, yeah, if you want to do the military thing, it also gets rid of all the costs, which is nice because they'll pay off all your tuition too. Yeah. Nice. Who's saying it's almost like nepotism but legal? Yeah, that's what the alumni network is for sure, dude. Let me go through all the chat here. Yeah, it is but bro, nepotism is how the world works. You know, they say your net worth is your network, right? It's the people you know. Yeah, I did go to UT Austin. Yes, they do have a very good math department. I did physics there, and I had a lot of friends in the math department at Point Gallis. Yeah, that was cool. Yes, you did work study at the AV department and Simplex. That's cool. Yeah. Also drink and party a lot. Yeah, I did do a lot of that, but don't do it too much, because I can't tell you how many of my friends ended up burning out the first year because they partied a little too hard. I agree. Go have fun.
I don't think I'll be partying. I think I'll just do gym.
There you go. Do the gym. Yeah, there you go, man. Yeah, the gym is the best place, dude. That's the best place to go party. Also, they're like lots of cute girls.
I think the Citadel says that my recommended weight at like 6'1" would be 205, like 17.
Okay. What are you at now? You're like 220, 230 or something?
I'm at 280.
Okay. You're a big boy. You could probably play football.
I don't. Some of the coaches in my school say why I don't.
Yeah, you could be a lineman, dude. 6'6" something and 280, dude. Yeah, you're a fucking center at that point. But also, like, protect your brain. Like, don't be banging your head against people. What is Point Gallis says? Yeah, Point Gallis, I definitely did that. So college was my time to branch out, become a free human, because I was very protected in high school. I never drank. I never did any drugs. I didn't party. I didn't do anything. Then I got to college, and I was like, oh man, I'm a free spirit. And so I ended up throwing a ton of parties. It was really great. But it depends. It's you know, find what works for you and balance work and school and stuff. It's only funny every once in a while. And yes, good group of friends is very important. Yeah. If you're just partying by yourself, that's not really fun. But I had, luckily, a very solid group of friends. You probably, too, do as well. Zach, do you have people from your high school also going to the Citadel with you?
I think I have like 3. Maybe
Fuck
more.
yeah, dude. Nice.
One I haven't seen since middle school. He's going.
Oh, cool. Yeah, so the great thing about that, and I did that too, because again, I went to high school in Houston, and then Austin, UT Austin was like 3 hours away. So a lot of, you know, I had a good core group of 5 or 10 friends that came to UT Austin, and that was a great base to have at college. And then you use that to branch out and meet new people in your classes. And some of my best friends to date in life came from my university experience. So yeah, definitely get out there. Gym friends are great. Yeah, exactly. I'm excited for you, man, dude. Man, if I could do it all over again, like people ask me like if I could turn a time machine back, I'm like, I go right back to 18. I would go right back to college and do it again. It was so much fun. It was the best time.
Yeah, my friend, he's going to the Naval Academy, and then one of my other friends, he's doing Marine Corps in the Citadel.
Oh, so the Citadel does Army and Marine, or isn't Marines like my ass rides in Navy equipment? Is that the acronym for Marines? But I guess, yeah, so they have a bunch of different branches there and whatnot. But the Navy, the Naval Academy is up in somewhere in Maryland, right?
Yeah, the Citadel has Army, Navy, Air Force, Marines, Space Force, and Coast Guard.
Space Force? Ooh! That's fun. And you think you'd pick Army? Because did you do Army as your ROTC for high school? I forget which one you did.
No, I did Air Force.
I did Air Force. Okay. Yeah. I love all the memes between the different military branches. I've seen the TikToks where they like describe like each one of it. One of my really good friends is a Marine. He was actually here on this podcast. He did 2 tours in Afghanistan, and he tells me some hilarious stories about the Marines. But I get the whole jarhead memes about them now. They're like the frat boys of the military branch are the Marines. Like kind of dumb but super fun and like just bro out all the time. Yashua has a friend at the Naval Academy. Nice. Yeah. Okay, cool. That's so good to hear from you, Zach. Let me help out one of these students with their math questions, but I really appreciate hearing from you and stopping by, dude. You're always more than welcome, dude. That's super dope.
Yeah.
All right, cool. Nice. All right, let's see. Asner, what are we doing? We doing the chain rule here? Yeah, okay, cool. Yes. So again, if we have two things that have x's in them and they're being multiplied by each other, and I want to take the derivative of that whole thing together, I need to do the derivative of the first thing times the second thing by itself, plus the derivative of the second thing, that's b prime, times the first thing by itself. Okay? So, and let's move this up. I love my whiteboard here because I move things around. Let's do it. Doing this, right, we know this needs to be a prime b plus b prime a. That is the product rule. So what we're going to do is we're going to take this thing, okay? This is a. And we're going to take the derivative of it, okay? So I'm going to be like, cool, I need to do d dx of this thing, and then I need to multiply it by b, which is just going to be this. All right, we're going to run out of room, but it's okay. We're going to move stuff over. And then we're going to add it to b prime times a by itself. Okay, so then that's going to be this. So we're going to say plus d dx of b prime times whatever this thing was all by itself. Okay. Some people get like kind of weirded out by all the boxes I use, but I don't know. I find it easier to understand visually if I'm like, because otherwise I start getting confused with, you know, all the stuff that's happening in between. It's kind of hard to see what's going on. Okay, so what I do first, I say, okay, cool. Derivative of the first thing. Okay, well, what was the first thing? The first thing was just x cubed. We know the derivative of x cubed from the power rule. You just pull down the exponent and drop it. And that's going to be 3x squared. Mika, yes, I can do your trig question. Totally. I got you. Sorry, I just saw that in the chat. Okay. And then times this. And this is like by itself. We're not doing any derivatives to it or anything. It's just we're just pulling it down. Okay? So this comes down. No, not that. Right? And so that's just going to be sine of 2x. Nice. Okay, cool. All right. Now let's go over here. So now I need the derivative of the second thing, right? B. So we need to do b prime. So that's the derivative of this. This is a little bit trickier, okay? Because the sine of 2x is technically a chain rule, okay? And I'll go into what this is. So let's try to figure out what this is. Like, what is d dx of sine 2x? Okay, so first of all, I don't really know what the derivative of sine of 2x is, but I know what the derivative of sine of something is, okay? So the derivative of sine of something, again, I love my boxes here, is the same thing as just the cosine of that something. Okay? But then, because I did this thing by, like, you know, getting rid of this 2x and calling it a box, I then have to multiply by the derivative of what was inside the box. This is called the chain rule, okay? And so this I can now remove, and then the derivative of what was inside the box, that's the derivative of 2x. The derivative of 2x, if this is 1, right, this just comes down, drops down to 0. Derivative of 2x is just 2. So this goes away and becomes 2. And so you get the derivative of sine of 2x is 2 cosine of 2x, right? So we're going to write that here. This is now 2 cosine of 2x. And then it's times the regular thing a by itself. So that's x cubed. So now we can rewrite stuff. Because usually you don't want to write like cosine of something times x of something. You want to put this stuff first. So I'm going to write it like this. I'm going to say this is 3x squared sine 2x plus, let's move this out front, 2x cubed cosine of 2x. And that is your answer. And you're done. Nice job, Asner. Ooh, 10 bond coins. Good job, dude. Sweet. Okay. Cool. Let me see. Obi says, I got accepted to nuclear engineering program in the Naval Academy, but the recruiter was way too excited about my 48 out of 50 on the entrance exam. Wait, oh, did they like scare you off, Obi? You're like, nah, dog, this is a little bit too much for me. Did you decide not to go because he was too excited? Did he like spill his drink on you or something? What I do, I have 10 points. You go buy tier 1 in the bank, and then you DM me what you want. There's directions there. Okay, cool. Let's see. Ace got questions. Darsh got questions. Let me see if I can help Mika real quick. Just she's been waiting in the stage. Here, Mika, you want to come to the front? Want to come say hi? What up, What up, Mika? How's it going?
Good.
All right, what are we doing? It was the. Let me find out which one it was. Oh yes, this one. Okay, cool. This one shouldn't take long. I got you. Oh, the ASVAB. Yeah. What is that called? It's the military SAT basically, I think is what it is. I've always wanted to take it actually, just to see how I would do, but maybe they would then like draft me for like whatever's coming up. It was slightly depressing. Yeah, well, I don't know. The military doesn't probably get the most competitive, like super high level math people going for it. But it should. I mean, also it has unlimited funding. If you've seen the black budget, the amount of money we dump into the military is like super high. So if you're looking for a job and you're smart, you will get paid. Okay. Solve for x from negative 2 pi to 2 pi, state all restrictions, and 5, all find solutions within the domain. Round answers to 4 decimal places if necessary. Okay, this is cool, actually. Okay. So we got 2 tangent of x plus secant of x is equal to 1. Oh, ew. It's kind of weird. Okay, so whenever I see this, I like putting everything in terms of sines and cosines. Just because I think it makes things easier, right? Okay. And then we'll check things. You know there are restrictions already, right? For tangent and secant. Just for, like, what you can put in there, right?
Yeah.
Like, what are we not allowed to put into tangent? I like to think about it this way. I'll show you. So let's remember tangent, right, is always going to be the opposite divided by the adjacent, right? And so if this thing like moves as like an angle, right? Do you see as I get like really close to here, my adjacent is like basically 0?
Mm-hmm.
Have you seen that before? Like I like drawing them kind of like this. I think I did a video on this actually.
I don't think I have.
Here, I'm gonna show you. This was like one of my first TikToks I ever did in my life. Keep going. Come on, TikTok. Let's go. Just because the animation's super cool. That's like 180. No, over 90. Okay, maybe it's this one. Well, it's actually, I want to do the ones where it's like, okay, here, sine, cosine, tangent at 0 at 90 degrees. Okay. So yeah, I like to think of things, this is called like the unit circle, is what it is. Do you see how the green is the hypotenuse, the red is the opposite, and the blue is the adjacent? Okay. So watch what happens as that angle goes up. Do you notice how the opposite is going up, 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 but the adjacent, the blue, is getting smaller and smaller?
Yeah.
Okay. And so as that angle gets closer and closer to 90 degrees, what does the opposite basically become?
Straight.
Becomes straight. And if this is the unit circle, right? The unit circle means the radius is always 1. So the maximum length that any line can be on that is 1. So eventually the opposite, that red line, becomes the same length as the green line, the hypotenuse, and they're both equal to 1. Once you get up to 90 degrees.
Oh.
Do you see that?
Yeah.
And then the adjacent, right, that blue line, that really small blue line right there, basically becomes 0. Okay. This is why, for instance, the sine of 90 is just equal to 1. Because the opposite is 1, right? The opposite was that red line. And then the hypotenuse is always 1. But the tangent, for instance, here is undefined. Because tangent is opposite over adjacent, and adjacent is 0. Okay? Yeah, that's why tangent breaks. I say like tangent like blows up here or something. Don't divide by 0. Don't divide by 0. Yeah, it's bad. Yeah. I made that video back in like 2021 or something. That's like 3 years ago. Anyways, so yeah, your restrictions on tangent is that you can't have it be here, can't do that, and you can't have it be here. Because then you're dividing by 0. Like your adjacent is 0 here and it's 0 here, okay? So this we know we can't equal pi over 2 or 3 pi over 2, okay? Secant is 1 over cosine, okay? And cosine, right, is adjacent over hypotenuse. So this becomes hypotenuse over adjacent, okay? Make sense? Which, again, same thing. I can't have the adjacent being 0, which is the same thing for tangent, right? Because tangent is opposite of adjacent. So this also has the same domain restriction, which is kind of nice. So I don't got to worry about 2 different domain restrictions. Yeah. Okay. Sweet. All right. So then the next thing to do here, I think, is to try to combine these. So what I'm going to do, I'm going to write tangent in terms of sine and cosine. Do you know how to write tangent in terms of sine and cosine?
Sine over cos.
Good. So I'm going to say this is 2 sine of x over cosine of x. And then secant, right, is 1 over cosine of x. And then this is all equal to 1, right? So now these are the same denominator. I can combine them, right? I can say 2 sine of x plus 1 over cosine of x is equal to 1. Yes, correct. Correct. Pongalis. You are correct. Yeah, we'll go over the negative ones as well. Okay. I feel like is this an identity? 2 sine of x plus something is something? One second. I feel like it is. Here we go. Trig identities. No, I want like the Wikipedia has a great page for them. Yeah. Let's just see. There might be something here. No, not that one. No, oh, it's 2 cosine squared minus 1. Okay. All right. Let's see. I maybe multiply both sides by cosine. Just like move this on the other side. If that makes sense, yeah?
Oh, yeah.
So 2 sine of x plus 1 is equal to cosine of x. Man, I need like some squares or something to like work out. Actually, oh no, never mind. I mean, I can do this graphically. I don't want to. I feel like there should be a way to do this analytically. But are you allowed to graph?
You could, yeah.
Yeah, graphing this, I can solve this in like 2
just
seconds.
a sketch.
Yeah. I can use the e to the it. Oh, thanks. Obi, yeah, Obi has a good idea with the double angle. Yeah, okay. All right. I'm tempted. What do you think I want? Which double angle Obi do you think I want to do? Also, yeah, Mika, do you know the double angle identities? Are those
Yeah, I think
those are in your arsenal? Yeah. Okay.
Mhm.
Because I want everything to kind of be the same trig function. And the issue here is I have sines and cosines. If they were like cosine squared or sine squared, that would be nice because then I could use the sine squared minus cosine squared identity. Yeah. Because I can turn cosine 2 theta into cosine squared. Fuck. And then I can only turn sine into sine and cosine. That doesn't really help me. Or I can do... Yeah, no, I definitely don't want to do the half angles. That's a mess. Yeah, I want them to be squared. Okay. Do you know about the e to the ix notation for this?
No.
No. You've never... Yeah, that's called Euler's formula for, like, doing trig stuff. Okay. I'm going to look for inspiration from ChatGPT because I just want to know what they're doing. And maybe maybe ChatGPT will point me in, like, the way that I want to do it. I'm just curious.
Wait, you
Okay,
can
so
send
here,
images?
this is what we did. We did this, right? I did this. Cool. Literally did this. Cool. Yep. All right. So me and the AI agreed to step 3. I agree there aren't... Okay. Okay. Numerical solutions are graphing tools. Okay, well, that was my next conclusion. Was to just graph this and figure it out. Okay. Yeah, that sucks. What? I don't want to do that. Yeah, but how would I do this analytically? How would I do step 6 without using a graphing calculator or can I not spell? Does my T button work? Come on, Clayter. There we go. Or numerical method. Poingallis says cosine of x minus sine of x is equal to the square root of 5 sine of a minus x, where tangent of a is equal to... Dude, where the hell did you get that, Poingallis? What? Excuse me? What? Okay. Oh, man. Oh, man. Yeah. Yeah. Oh, that is cruel. They squared it from the beginning. Oh, okay. Wow. Ew. Okay. I'll show you. It's kind of a cool solution. I kind of like it. That's right. Okay. So my original thought of just like turning everything to sines and cosines kind of reached like an impasse here, unfortunately. Which I wonder, wait, can I just square both sides here and like figure this thing out? I feel like I might be able to. Because I'm going to get cosine squared. Yeah, no, let's do it from here. I think I can square it from here. Let's square it from here. I'm just going to square both sides here. All right? So we're going to do this. We're going to square z. Okay? So now this is going to become 4 sine squared x plus 4 sine of x plus 1 is equal to cosine squared of x. And so, yeah, good, Jeff. Yeah, this is what I was looking for. Because in general, when you want to do things with trig functions, you want them to be squared. Because these identities start to like pop out. Do you know that sine squared plus cosine squared is 1? Mika, did you know
It
this?
looks familiar.
It's a very important question. Yeah. You want to know this one. And then you also want to know that, what is it? 1 plus tangent squared of x is equal to secant squared of x. That's another very important one. Yeah, you should know that one as well. Okay.
Okay.
All right. So from that, I can now write cosine squared as 1 minus sine squared of x. Okay? Okay. So this is 4 sine squared of x plus 4 sine of x plus 1 is equal to all this. Okay. This is about to become a quadratic. Yeah, I know. All right, okay. So let's move this over. Let's move this over, right? So now I have 5. I see, Point Gallus, where you got this from. Now, yeah, nice. Okay, 5 sine squared of x plus 4 sine of x plus 2 is equal to 0. Okay? I'm going to say, because do you see how I have something squared, something not squared, and then something just not even there? Y plus 2. Oh, yeah, I fucked up. Actually, you know, I fucked up. Thank you, Jeff. Bless you, Jeff. Yeah, sorry, I said it should have subtracted 1. This is actually just 0. Jeff, you get a save. You get a save for that. Good job, Jeff. Jeff lives for the saves. Okay. Actually, now this is not a quadratic. Kind of cool. Dude, what? Wait. Wait. Do you want to see something funny here? One sec. Did you see how it's being held on the leaderboard? Yeah, one sec. Obi, you're gonna love this, dude. This is hilarious. So Jeff tried to get the leaderboard to work because he wanted to see who was it, and then Automod held it for bullying because it saw and in Simplex's name has a racial slur in it technically. I guess I'll allow that. I don't know. Whatever. Yeah, your name's not a racial slur, dude. It's okay. Okay. All right. Let's keep going. All right. So this is actually pretty cool. So this went away. So actually, this isn't a quadratic anymore. Because now I can move this over, and so we have 5 sine squared of x is equal to negative 4 sine of x. Okay. So what I can do is I can divide both sides by sine of x. Right?
Yeah.
Now, to be careful here, though, yeah, Jeff, you're right. Yeah, exactly. Whenever you divide by stuff, you have to make sure that it being 0 isn't also a solution. Okay? Because technically, you're getting rid of sine of x being 0 as a solution. It's like this. If you have, for instance, like x squared equals x, right? And you divide both sides by x, do you see how you get just like x is equal to 1?
Yeah.
Okay. The issue is that also, if you were to plug in 0, 0 squared would equal 0. So you accidentally forgot the, or you accidentally got rid of the x equals 0 solution. So technically here, sine of x can also equal to 0. All right.
Is that like confirmed?
It is confirmed because even from here, right? Let's say, for instance, I put in some value of x such that sine of x was 0. I'd get 0 plus 0 is equal to 0.
Oh, okay.
Yeah. The safer way to do this, I agree, Jeff, is to factor out a sine of x from here. So do this. So let's say sine of x, and then let's do 5 sine of x plus 4 is equal to 0, okay? Now you know, like from factoring, right? When this is equal to 0, it's a solution. And then when this is equal to 0, it's a solution.
Mm-hmm.
This is a way to preserve that equals 0 solution. But I know students are most likely to just divide both sides sometimes. Okay, so we either have sine of x is equal to 0, okay? Which means x is equal to the arc sine of 0.
What's that?
Or 5 sine x plus 4 equals 0. So sine of x is equal to negative 4 over 5. Or x is equal to the arc sine of negative 4 over 5. Okay? And then these things have periodicities to them. Right? Like once you get an angle, it also works for a couple of the other ones as well. Wow, a 3, 4, 5 triangle. Oh, it is actually. Oh, that's super fucking dope, dude. What? That's super cool. Okay.
When you use arc sine, is that like the same as inverse sine?
Yes. Yeah, I in general don't like saying inverse sine because people then think it's cosecant because it's like
Oh,
1 divided
okay.
by it.
Yeah.
There's a debate in the math community whether to use sine to the -1 or inverse sine versus using arc sine. And I think arc sine is winning the popularity contest. Correct me if I'm wrong. I think people like arc sine. But you're right that on a calculator, right, it just says like sine -1, right? So if we do sine -1 of 0, you would get that this is 0, right?
Okay.
Okay. But then you have to think about like where else that occurs. Okay, so like where else is the sine of an angle equal to 0? So yes, it does occur here, right? It does occur at 0 degrees or 0 radians, right? But where else is the sine equal to 0?
Pi.
Yes, good. At
2
pi. At pi over here, right? And then also coming back at 2 pi. All right? So looking here, right? Because on our restriction, right? It was 0, it was pi, it was 2 pi. And also, if we go backwards, right? If we go to negative angles. So if I go to negative pi and negative 2 pi, I also have the sine of that angle equaling 0, right? So negative 2 pi and negative pi are also solutions. But I think ChatGPT got rid of those. Why did he get rid of those? Oh, no, it's okay. Negative 2 pi, 0, 2 pi. Why did he get rid of the pi solutions? Excuse me? Let's see if that's right, actually. I'm curious. What's up, Geoffrey? How do we know when we have to find a reference angle to solve a trig equation? Also, do you like cats? So either they'll state like find the reference angle, or whenever you're finding the sign of angles that are bigger than 90, you want to draw like a reference triangle. So I'll kind of show what I mean by that. So if for instance, if you have a big angle, let's say you have, what is it, like 120 degrees, what you're really doing is you're solving this triangle where the angle is just 60 degrees. So like the sine of 120 degrees, which again is opposite over hypotenuse, is really equal to the same thing as the sine of 60 degrees, where this is also positive. Yeah, I'll get to it later, Osner. Yeah, I get to it usually same day. What I'm curious is why does ChatGPT not like the equal to pi solution? Let's check that actually. If I plug in pi for tangent, tangent of pi is 0. And then the secant of pi is 1. Right? Because it's 1 over the cosine. Cosine of pi is 0, is 1. Or no, 1 over cosine of pi is -1. Interesting. How did we lose that solution? Oh, interesting. Wait, whoa. Oh, you want to know something? So, Mika, you want to know something? Sorry, special. We have to figure out here. Yeah, when we did this, Mika, the squaring. Yeah, no, it's ChatGPT is correct. We're gonna accidentally introduce more solutions than there are actually possible. Because, okay, let's say, for instance, I say that, like, I'm trying to think of what an example of this. Like x minus 2 is equal to 3. Right? Okay. If I like square both sides, right, I get x minus 2 squared is equal to 9. And then technically there are a couple solutions that this works for, right? This works for what? This would be like x equals 5, or x is equal to -1. But in reality, if I plug that back in, that does not work as a solution.
Oh.
Good to see you, Zach. Thanks for stopping by, man. And yes, I do like cats, Joffrey. I might be having someone with a cat visit me in like a week or two. They need a closer place to get to the business meeting. And then they told me, they're like, oh, I got to make sure.
I think your mic cut out.
Dude, we can't hear you.
Okay, there you go. You can hear me now? Yeah.
Yep.
Yeah.
I don't know. My USB hub's been messing up recently. I think, Amika, I asked you, like, what type of cat do you have?
Oh, I have a dog.
Oh, you have a dog. Okay, cool. I don't think I could have a dog in my apartment because my apartment's too small.
Oh yeah,
Anyways.
my dog is like a foot long.
Oh, a foot long. There you go. It's a small dog. It's a small dog. Okay. So what I was saying here, Mika, is that because we did this squaring thing, we're technically going to introduce solutions that don't actually work. And so we have to make sure that we check those later. So this is what we got so far. And what happened is if I tried plugging in pi for this, so this would go away. The tangent of pi would be 0. But the secant of pi is equal to -1. And -1 does not equal 1. Right?
Mm-hmm.
So that's why, yeah, ChatGPT is not wrong. ChatGPT is right, but sometimes, it's wrong, but it's right this time. So I need to get rid of the solutions that are over here. So that's going to be pi and -pi. So we're not going to have this one.
No.
And we're not going to have this one.
No.
Okay? So this is what we have so far.
Okay.
All right.
Because it
Last-
makes secant invalid.
It's not that it makes secant invalid. It's that it makes secant equal to -1. And I need it to be equal to +1 to solve this correctly.
Okay.
Yeah. So, okay. So then we got this. So the arc sine of -4/5. So I like these. These are always kind of fun. So what I'm going to do here, I like to draw like what the thing looks like. And to your point, Joffrey, this is kind of like the reference angle thing. So arc sine of -4/5 says that the sine of some angle is equal to -4/5. So where -4 is the opposite and 5 is the hypotenuse. Right? Because sine is opposite of hypotenuse.
Mm-hmm.
So let's draw where that could happen, right? So I could either have the opposite be -4, which would be down here. And the hypotenuse would be 5, right? So we could say 5, and then have this be, right, -4. Or I could have it happen over here. Because in this case, right, the opposite is -4, and the hypotenuse is 5. All right, so there are two different angles this works for, right? This works going to here, and also going to here. And then it also works for the reverse cases, which would be going this way and then going all the way this way. Notice how none of them work here, right? Because the opposite here is always positive. So, yeah. This is how you figure out. I like to just draw it where it is and then think about, okay, well, how many times do I need to go around to, like, what's my domain that I'm allowed to hit? Okay, so what I'm going to do is I'm just going to figure out like what this angle is as like a triangle. So let's just do it like this. Let's just say, okay, let's pretend this is 4 and then this is 5. Then let's figure out what this angle is. And we're going to do that using the arc sine, which is also inverse sine, as you pointed out correctly. So I'm going to say sine -1 of 4/5. And then let's make sure let's put this in radians, because I think that's how your teacher probably wants it, right? And so that's going to give me 0.92. Okay. Yeah, that's fine. Whichever one you're actually struggling with, Ace, I'll do it for you. Okay, so this whole thing is 0.927 radians. Okay. So I have a couple solutions, right? I have negative 0.927. 0.927, right? Because that's the angle going this way. Does that make sense, Mika? The radians are weird, honestly.
So that would be.
Let's put it in degrees, actually, just because it's hard to visualize things in radians because we've been taught degrees our whole life. Right? You're like 0.927, like, what the fuck is that? Okay. Good. Okay, 53.13 degrees. Okay. So I know that this is like the reference angle, right, is 53.13 degrees. Okay? So negative 53.13 degrees works, right? That's how to go this way. And then if I wanted to go all the way around, what would that be?
Can you repeat that?
So if I wanted to describe, here, let me make a little thick thing here. If I wanted to describe the angle going to here, right? We know that's negative 53 degrees because that's going clockwise, right? But let's say I want to get to that angle going this way. How many degrees would I have to spin?
It would be 360 minus that.
Good. Exactly. So it's also going to be 360 minus 53.13. So 360 minus 53.13, which is also going to be, what's that? 360 minus that? So 306.87. Okay. All right, cool. So we've solved this one. Now let's do this one. Right? So I can see pretty easily to do this, right? We know that this is 53.13. So what would it take for me to go this way?
Plus pi.
Good. Plus pi or plus 180, right? Okay, good. So I know that 180 plus that, so that's 233.13 is valid, right? And then what would be the one coming clockwise?
Plus.
Jeff's like, wait. Yeah. I know, Jeff. My math looks sketchy sometimes. So, yeah, this one's kind of weird, right? So this would be negative 180, right? Coming all the way this way would be negative 180. But I want to stop 53 degrees before that. Right? Because then this amount is 53 degrees.
Pi?
Good. So, well, no, it's not plus pi. So it's, here's what it is. It's kind of weird, right? It's negative 180 plus 53.13, right? Because negative 180 gets me all the way to here, but then I want to add 53 degrees to get what this amount is. And it'll still be negative.
Oh, okay.
Do you see that?
Yeah.
Yeah, that's kind of a weird one, right? All right, so then that is going to be a bigger angle, right? So what's that? That's negative 180 plus 53.13. Oh, I didn't type my syntax incorrect. Fuck. All right. No, not that one. Where's my... Come up. There we go. Negative 126.87. Okay. I'm just adding and subtracting 360. Yes, sometimes, but then sometimes I'm adding and subtracting 180. This is the tricky thing about arcsine, arccosine, and arctangent, is the periodicity is not nice just n pi, n pi, n pi. As you see here, right? It's like this one, but then it's also this one. It's weird. So I forget like what the hard and fast rules are for it. And also, they're kind of a pain in the ass to memorize because it changes whether it's sine or cosine and whether it's negative or positive. So I just draw them on a coordinate axis, and then I can see it. But once you find two base solutions, you can subtract 360 from each. Yeah, I guess you could. Does that work? Yeah, maybe. Yeah, once you find this as a solution and this as a solution, you're right. Then you can add and subtract 360 from them ad nauseum as long as it stays within, right, 2 pi. But I feel like that might, I don't know, I would miss some of them. I just like drawing it, and I'm like, okay, what's this? What's this? And then like, okay, cool. Well, what's this? What's this? Fair enough, yeah. They're both right, but yeah, I don't know. I'm a visual guy. I like visuals. Okay, so we now know that all of these are possibilities, but some of these are going to fuck up because of the squaring of what we did. So technically, I have to test them. So unfortunately, yeah, there's not really a fast way to do this, I think. I think you literally just have to test them. So if we do 2 tangent of negative 126.87. Well, here's what I'm going to do. Do you have a TID3 when you do stuff?
No.
No? Okay, because this is a cool thing. You can write this as a function. So I can say, look, 2 tangent of x plus secant, which is, right, 1 over cosine. 1 over cosine of x. And then I can just tell it to, like, do this, okay? But then I can tell it what x is. This is kind of cool. So watch. I can say 0 implies x. And then you can go right back up and tell it to do it. And I get 1. And I'm like, cool. 0 works. It's just a faster way instead of, like, having to keep typing things in. So I can say 126.87 implies x. Let's do the same thing. That equals basically 1. Okay, so that one's probably okay. So this one's okay. Negative 53.13 implies x. Let's run it again. That's negative 1. See, this one is no. No. Right? That's the squaring problem we had to solve this. Is that we are going to introduce solutions that are extraneous. This one works. And then I'm guessing the next one doesn't. Yeah, next one doesn't.
Oh, no.
That one doesn't work. Okay, cool. So then here are your answers. It's negative 2 pi, 0, 2 pi, and then this one, but convert them into radians.
Okay.
That was a very long
How
question.
come it says 5 solutions?
Oh, there are 5? Well, fuck. Oopsies. All right, let me see. 0, 2 pi, negative 2 pi. Wait. Yeah, that is 5. That is 5. I found 5. Yeah, sorry. Look. This is a solution. This is a solution. This is a solution. This solution. This solution. Yeah, there's 5. Cool. I'll send you the image of this. Nice. Good job, Micah.
Thank you.
You're welcome.
Well done! Well done!
Yeah, that was a fun one. I thought it was going to be easier and not as long, but then, yeah, to do it analytically, you do have to. But there are a lot of cool things in there. A lot of, you got trig identities. You got just learning how trig functions work. You got inverse trig functions. That's what I would call a solid problem. Gold, you can do mine. I got to work on my essay due tonight. Yeah, I'll do yours, Equity. Yeah, sure. And then Ace, can I get you?
All
right, cool.
Thank you.
You're welcome. You're welcome, Mika. Which we need help with, Equity? Sorry,
Vegeta, what does the scholar say about his power level?
That's over 9,000.
Oh, no.
Oh, no. No, not this.
Oh, no.
Oh, no. All right, and then Ace, I swear I'll do yours. And then I got Adarsh and... oh, Ace, yours looks actually kind of fun. You have a fun question. Gold, have you read Lord of the Flies? I have. I really empathize with Piggy because I also had glasses and was like chubby in elementary school, in middle school. And I was also kind of the brains, so I'm sure I would have had my head bashed in for being too smart. Oh, sorry.
Have you read
Laz.
Mein Kampf?
Have you read Mein Kampf? Stop. Do short pre-lecture quizzes count towards good grades, bond coins? Sure. You have actual quizzes, though, don't you? Yeah, just submit your real quizzes. You have so many quizzes, and you do well in your quizzes. I always say, like, I give students, like, some slack on their first one. Like, someone will literally just show me, like, a piece of paper with, like, a check mark on it. I'm like, all right, whatever. Like, you tried. But if you've been here for a bit, show me a quiz. Show me a test. Yeah, sure, man. Yeah, I can look at your essay. I'm gonna be kind of busy, but when's it due? Is it due tomorrow? Oh, it's due tonight. Oh, okay. Well, yeah, I can try. I have a pretty packed schedule after this. But I can run it through ChatGPT as well. We'll see what ChatGPT says. I pay for the full version. And ChatGPT is actually pretty good at analyzing, again, language models. It is a language model. And I'm working with a company actually to use it to auto-grade history essays. So what we can do is we can feed to ChatGPT, like, this is a paper that would get an A, this is a paper that would get a B, this is a paper that would get a C. Given this student's paper, what grade would you give it? And it's actually surprisingly accurate at, like, based on, like, what a human would score. Yeah, ChatGPT is great at feedback. If you want to see some examples of, like, me using ChatGPT for feedback, I used it on... Yeah, EDI statement here for UCLA. Like, I did this, for example. I said, hey, make suggestions to improve my EDI statement, given that this is the rubric. Like, I literally gave it the rubric that they used to grade it. And then, yeah, it thought for 21 seconds, and it said, oh, you have a good idea, but maybe provide some specific examples, elaborate on your strategies, highlight experience, include research contributions. Like, it gives a lot of really good suggestions. And then it gives some examples of, like, hey, maybe you should switch this. And then I did it using their other algorithm and also did some great stuff here. Like, I gave it and it said, okay, here, you should do this, you should do this, you should do this. And then it gave some, it revised some of my essays, said, hey, maybe write this like this, maybe write this like this. And it's pretty cool. So, yeah, no, ChatGPT is great for feedback on essays. I don't have any essays that got an A, B, or C. Yeah, no, that's okay. You don't need it. I'm just saying I'm using it with this textbook startup to grade essays. And yeah, Laz's sorry. Yeah, if you get the criteria. Yeah, so equity, if you have the rubric that your teacher gives you for how they're going to grade it, ChatGPT is exceptionally good at making sure your paper fits the rubric. So yeah, try it out. But yeah, and you're all good, Ace. I think he still has to write the essay, so he's talking about later tonight. But yeah, let's do his question, and then we'll let him work on his essay while I help you out, and then if I have time, I can do some little suggestions for your essay, equity. All right, given an increasing list of consecutive integers, the three-signed sum of the list is the sum of the integers in the list. Why are there so many words here, dude? What? So many words. Oh.
Hello there.
General Kenobi.
General Kenobi, you are a boy.
I love that scene. Okay. For example, the three-signed sum of the list 3, 4, 5, 6, 7, 8, 9 is 3 plus 4 minus 5 plus 6 plus 7 minus 8 plus 9 is the sum of the integers in the list in order except that every third integer is subtracted. Oh, very cool. Okay. So, yeah, this is 8 plus 9 minus 10 plus 10 plus 11 plus 12 minus 13 plus 14 plus 15. I see. They put a negative sign on every third Okay. Okay, for every positive integer n, a slice of the list 1, 2, 3 to the n minus 1 n is an increasing list of at least one and at most n consecutive integers. Each of which is between 1 and n. 1, 2, and 3 and 4 are both slices of lists. Oh, okay. And they're consecutive. Okay. For the positive n integers, the Guy-Meir number of n, denoted g of n, is the sum of the three signed sums of all slices. 1, 2, 3, for example, using the information above. 0, 3, 5, 1, 2, 3, 14. For each integer n is greater than or equal to 1, show that g of 3n minus 2g of 3n minus 1 plus 3n minus 2 over 3 is a perfect square. Oh, Christ. Okay. Okay. Let's maybe just try to get a formula for this, right? So, g of 3n. So you're at least always going to have these individual sums, right? You're going to have, what is it? 1, 2, 3, 4, ... 3n. And those are all going to add up. Okay, so this is going to equal to the sum from, let's say a equals 1 to 3n of a. That's what these slices are going to be. And then you have all these ones, which, how does that work? So see, 1, 2, 3 goes 0, 3, 5. So 1, 2, 3 is 0, 3, 5. Is there a pattern here maybe? Let's look at 1, 2, 3, 4. So 1, 2, 3, 4 has all the slices beforehand of 1, 2, 3, 1, 2. Wait. 1, 2, 3, 4 as 1, 2, 3, 1, 2, 2, 3. It also has 1, 2, 3, 4, which is 1 plus 2 plus 3 minus 4. Wait, no, it's 1 plus 2 minus 3 plus 4. Wait, 1 plus 2 plus 3 minus 4. Yeah, okay. So that's 3, 6. 6 minus 4 is 2. Wait, what? Wait one sec. No. 1, positive 1, positive 2, negative 3, positive 4. Okay, so then this is equal to 4. And then you have the new one, 2, 3, minus 4. And then you have the new one, 3, minus 4. So this is equal to 1. This is equal to negative 1. Am I missing any other slices here? Oh, and it's not 3, negative 4. Sorry, it's just 3, 4. It's equal to 7. Right, okay. I was hoping I see a pattern here. So I see 0, 3, 5, and then 1, 4, 7. Doesn't really help me out. Then if we go to 5, I get 1, 2, negative 3, 4, and then 5. So that's going to give me 9. Then I have 2, 3, -4, 5. That's going to give me 6. Then I have 3, 4, -5. It's going to give me 2. And then I have 4, 5, which is going to get me 9. And then plus all the other ones. How weird. How weird. How weird. What? I don't see any pattern. The nominees for Stump the Streamer? Yeah, this is just fucking weird. It's a weird question. Huh. Because first of all, I've never heard of a Geimeier number. I've never heard of 3-sign sums. And I'm not seeing a pattern. Usually there's a pattern that I see this. I see that, like, as you go up to higher and ends, the 3-sign sums of the original numbers is just A equals 1 to 3n of A. Like, that's fine. But then these, like, what is the math of the 3-sign sums? Let me see. What's that? Like, patterns. Like, why would I know this? Machine learning. Oh, is this guy like a super boss guy or something? No. Bum, 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 bum. Let's see. What are you adding? You're adding 8. You're adding 12. You're adding 12 to the sum here. And then you're adding 15, 17. 26 here. I don't know, Equity. Where the fuck is this book from, dude? What? Why is this book so tricky? What the fuck is a Geimeier sum, first of all? Here, I'm gonna post this in. So wait, is Zach streaming later today? I will give this to Zach. If you Google it, there's only one result in Chegg. Yeah, I bet it's been done before. Is it this one? What would it be? It would be like Chegg, Geimeier, 3-sign sum. Send me the Chegg link you found, Jeff. Have you got it? I'm curious. Oh, you just search for Geimeier number. Thanks. Okay, add 8. Okay. Yeah, we already did this. Okay, cool. We can see that g of n is g of n minus 1 plus n. Is it? Does G4 equal G3 plus 3? That doesn't work. Oh, and then they just use modulo. So they kind of went at it the same way I was doing it, Equity, which is you just start doing some of them and you try to see like a pattern. Although I don't know if I agree with their pattern. But okay, maybe. Yeah, whatever. Cool. I'll give you credit for it just because it was hard as fuck, but yeah. Let's see if Zach can do it.
Well done!
What question was that from? Like where is this just like a math of like let me beat you with numbers? I feel like it's the Waterloo math contest. Oh. Yeah. Wait, was this the thing you just took? Oh, so that was on the test. Wow. Let me see if Zach is streaming today.
Nice.
Zach is at 6:30. Oh, thanks for the follow, dude. Oh, sweet. So Zach is on at 6:30. Here, I'm gonna dump this in his form. What's up? What's up, D-host? How you doing? How's your how'd you find us? Did you find us on Twitch? Oh, we're still streaming in the just chatting category. I'll have to check to see if it's doing better for follows, yes or no, compared to being in the was it science and technology group. All right, let's help out. How's everyone doing? We're doing great, dude. Just helping out some math and science questions. We just had a Waterloo math challenge question. It was pretty tricky. Let me see. Is Adarsh here? You around? Or Ace? Okay, cool. Adarsh is a dookie, I guess. All right, Adarsh, let me do yours real quick. And then Ace, I'll do yours. Or Ace, let me do... Yeah, actually, yeah, Ace did submit first. Let me do Ace first real quick, and then Adarsh, I'll do yours. Just searched on Twitch math, and you popped up. Oh! Super cool! Well, thanks for finding us, man. If you want to know some other awesome math streamers, there's all of them. Those are all our friends, and we all stream math help at different points during the week. Some people even do like free courses on stuff. And then if you ever want to see the calendar of when they're streaming, we have this Google calendar that shows what's happening. So Zach will be on later doing math stuff. Penn Center tomorrow, Zach, and then there's abject algebra, and then yeah, some fun stuff happening over the weekend. So feel free to check it out. Yeah, glad you found us. All right, let's do yours. Okay, a box in the length. And yeah, feel free if you want to like help answer these questions with us. I don't know what level of math you're in, but we always welcome help from the audience. Square base prism has a base length of 10 and a height of 20. Okay, so this is 10, this is 10, and this is 20. A rod is dropped, one corner to the opposite. Determine the angle between the rod and the vertical edge of the box. Oh, man. Is this where I have to do things in like 3D coordinates to start doing like dot products and cross products? Yeah, here's a good question, Aced. Do you know about angles? I mean, and dot products and cross products? Am I allowed to do that? Maybe? Yeah, he doesn't know what a dot product is. Like, do you know vectors? Like, if I do vector, like, in this case, it would be 1, comma 1, comma 1 dotted with, like, 0, comma 0, comma 1. That's what this would be. Have you ever seen this before? If I want to get good at math, where do I start? Recommend any books? Depend. What level are you at? Are you an adult coming back into math? Or are you in middle school? Your high school, college?
Nice.
Math major 7. What's up, dog? Thanks for the follow, bro. And then use some trick. Okay, dog. Yeah, you right. Yeah, I wanted to do dot products and vectors because they're fun. But you're right. He hasn't done it yet. Okay. Yeah, that's fine. Yeah, okay. So he brings up a good point. So we have to kind of look at this at from perspectives, I guess, and whatnot. It's kind of weird. But anyways, yeah, let's figure out what the length of this thing is. So you can do the distance formula, right? Have we done that before? Have we done the distance formula before? Maybe. But let's say, for instance, I was looking straight down, like this way. Okay, what would I see? I would see a square. Wait, this is a square. Electrician working on going for my electrical engineering degree, and I desperately need to study math. Cool. You probably want to start just with some basic algebra and stuff to make sure you remember the core stuff to be able to do math. And then I think electrical engineering is going to require you to know calculus. So you basically, your goal should be getting up to being ready to take calculus. And doing whatever is necessary to get to that. I have I think I do have some books. One second. Let me find you a book real quick that I use. Root of 200 to find the width. Yeah, I agree. Wait, textbooks. Okay, yeah. Here's what I would use first here. D-host. Yeah, I'm gonna give you a link. This wants to load. There you go. Okay. This is what you want to work yourself up to. You want to be able to do calculus. This textbook, for instance, does have what's called like a pre-calculus review in chapter 1, I want to say. So this would be a good thing to see how much of this you remember, for instance. And if there's stuff here you need reinforcement from, like, for instance, the distance formula, some domain and range stuff, you can always, there's a gazillion tutorials on YouTube that can teach you this. Or you can come by our streams here and ask questions about this, and I'd be happy to teach it to you, man. But this is what I would start with this first chapter, and then you're basically going to be building up to get ready to calculus. Here, I'll give you the link for this. Where's a copy? Where's just a fucking link? Copy link, please. There you go. Hey.
Link, please.
Links, please. Copy. Yeah. Yeah, many of them have chapters there. So yeah, let me know if that works. That's my favorite calculus textbook I like to work out of. And just try to go through, yeah, as Obi says, chapter 0 or like the first chapter. And see what you know, see what you don't know. Okay. Yeah, okay, so this is 10. This is 10. So the diagonal that we we kind of see as this is coming up is going to be the square root of 200. I agree. Cool. Square root of 200. All right. Determine an angle between the rod and the vertical edge of the box. Okay, cool. Okay, so looking like kind of at the angle, I guess, right? This is going to be the vertical edge. The top is going to be the square root of 200. And then the line that connects it down, okay, is going to be the square root of the square root of 200 squared plus 20 squared.
I thought they shut down the Internet Archive.
Oh, maybe they did. Math Major seems to think it still exists, so you can check that. Yeah, the other one I know is free. If you guys want to do is OpenStax. OpenStax is the ultimate like free. What I gave you is technically illegal, but whatever. Like fuck the textbook companies. But if you want, but if yeah, here you go. Just do this. These are also very good. But just go to OpenStax, and they have all sorts of algebra, pre-algebra, mathematics. These, and they have solution manuals and everything. So you can. I would maybe start with pre-calculus, and if that's too hard, go to algebra. If that's too hard, go to pre-algebra. And then yeah, these are all great. These are also really, really good things. Really good resources to have. Okay. So, aced. I know that this is the square root of 200, and I need to figure out what, like, this distance is, right? Okay. So, I can do this. So, the whole length of this is, like, this and this has to equal to this. We could use arctangent. Yeah, you're right. Man, that's no fun. Yeah, he's right. Fuck it. Whatever. Okay, we can just do this. Cool. All right. Yeah, done. And then I wanted to find the hypotenuse, Jeff. Okay. Tangent -1 of opposite over adjacent. So that's going to be the square root of 200 over 20. Let's figure out some stuff. Maybe it comes up. Let's see. And then I want to show you how to do it with vectors. I think it's pretty cool. Arctangent of square root of 200 over 20. Gonna get you 35.26 degrees. You can amuse yourself on your own time.
Oh no! Oh no! No, 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 no.
Okay. It's 35.26 degrees. Yeah, correct. Good. Do you understand how I got that? Yeah. Okay, good. Good job.
Well done! Well done!
If we have time later, I'm going to show you how to do it with vectors. It's so much cooler with vectors. I appreciate you, Jeff. Jeff's always watching out for me, dude. Good job, Jeff. I appreciate you, man. All right. Anuki, what's up? Let's do your question. This looks like 3 variable systems of equations. What's up, dog? Yeah, okay, cool. All right. What class is this for? Like, is this a linear algebra class? Is this a pre-calculus class? I want to know what techniques I'm allowed to use. 3x3 augmented matrices. Fuck yeah. That's what I wanted to hear. Yeah, let's do it. Okay. Right. Anytime you have a systems of equations and it's in this nice little form like this, we can write this out as this. So this, I can just look at the coefficients, okay? So in that case, it's 2, 6, 3, 2, 1, 3, 1, 1, 1, 5, 2, -1. Okay, cool. Do you know what the goal is here? to turn this matrix into? Like, what am I trying to get this into? I don't understand what is a coefficient and a polynomial. Okay, good. No. Please ask questions, D-host. That's what I'm here for. Okay. Poly, all the rage now with relationships, means many. And then nomial, it means terms. Okay. So a polynomial just refers to something that has many terms. Hey, what's up, Sor? Oh, fuck. Welcome back, Sor, dude. I haven't seen Sor in forever, dude. So this is a polynomial. This whole thing is a polynomial because you see how it has many terms, many different things. The coefficients are these. These are the coefficients. Coefficients are just the numbers in front of the letters. Those are the coefficients. Sora, what's crack-a-lackin', dude? How's high school, man? You're a junior now? We just had Zerudo come in and tell me he got into college. Congrats to Zach. I'm so happy. That made my day today, dude. Like, what? That's super dumb. Ads are too long? Oh, I'm sorry. Yeah, go yell at Jeff Bezos. Yes, very good, Aduki. Yeah, exactly. So, okay, so what I did here, and this is an advanced topic, D-host, by the way. The simpler thing is to solve just a regular systems of equations, like a 2x2. Like, say, for instance, you have, like, two numbers that add up to 6, but the difference of them is equal to 3. You could solve for what this is. In this case, you would, well, actually, let's make it something nicer. Let's say they add up to 6 and they subtract to 4. You could add these together. So this would be x plus x, which is 2x, plus y minus y is 0y, and 6 plus 4 is 10. Divide by 2, divide by 2. You get cool x equals 5, and if I plug back in, y equals 1. I'm just doing it quickly. I don't expect you to follow it completely. But basically, if you have a condition, right, like two numbers need to add to 6, and their difference needs to be 4, I could use a system of equations to figure that out, which would be that, oh, x would be 5, and y would be 1. Because look, add them up, it's 6. Subtract them, 5 minus 1, you get the difference, which is 4. That's a simple 2x2 systems of equations. It's called 2x2 because you have 2 equations and 2 sets of terms. This is a 3x3 because I have 3 equations and 3 things I don't know, right? I don't know x, I don't know y, I don't know z. But I know that twice x plus 6 times y plus 3 times z is equal to 2. Oh, thanks, Sam. What's going on, dog? Appreciate. I need a drink. Drink some water. Do you still be playing games for recess? On the weekends. We don't do them after the stream anymore. And honestly, I've been bad at playing games over the weekends. I will do it this weekend. I promise to God I will play Fortnite with you guys over the weekend. Yeah, cool. All right, we'll do it. Anyways.
Hey, Gold.
What's up? What's up?
What do you call a kid with no arms and glasses?
Oh, God. No arms and no glasses.
Names.
What? You're going to have to explain that one to me.
No, never mind.
This weekend Fortnite? Yeah, for real. Let's do it. Yeah, I'll set it my schedule. No one's taking my time away from you guys, and we're going to play Fortnite. Because I want to play the newest season. I heard it's fucking dope.
That's dope.
Anyways, i.e. tease me? Call him names? Oh. Man, that's got to be such a British humor thing, dude, because we don't say call people names here. We just say insult them. Oh, that's
he was an Australian who had that joke from.
That's a good one. Call him names. Tease me. Uh-oh, Freudian slip. Okay. Yeah, so the goal here, Anuki, is to get this part of the matrix to look like this. Do you know the strategy for how to do this? It's a Bo Burnham joke. It is fallen on common usage. Oh, I do like Bo Burnham. He's pretty fun. Yeah. So, yeah, so there's a method that always works, and this is how, like, calculators work to do this, and it's called, like, the snake method. They do this. Okay? So what they do is they work on this number to make it a 1, then they work on this to be a 0, then they work on this to be a 0. Then they come up to here, they work on this to be a 0, then they work on this to be a 1, this to be a 0, this to be a 1, this to be a 0, this to be a 0. And doing this little snaky pattern, whatever, like, works out every time. There's a name for this. There's a name for this method. What the fuck's it called? Call it Euler's method or something? I don't know. It's some dude. Jacobian, maybe. But anyways. Okay, so here's what I do. So the first job, right, is to make this thing right here equal to 1. How would I do that? How would I make this first 2 equal to 1? And yeah, you have to do row operations the entire time is what it is. So what you could do, minus 1 from row 2. Yeah, that would work out. Yeah, let's do it. You could also divide this by 1. Divide this by 2 if you wanted to, but I kind of like your solution better. So yeah, let's call this like 1, 2, 3. So I'm going to say 1 minus 2 gets me, well, oh, it's called Gaussian elimination. Thank you. Yeah, let's give math major a saves, dude. Thank you, math major. So yeah, so I'm going to take row 2, subtract it from this, and then reinsert that as row 1. All right? So now, my new matrix is going to be 1, 3, 2, 1, and then we have the same stuff here. Okay? Cool. Next step is to make this a 0, right? So we could do the same thing, right? I could take this and subtract this. Here's the key thing, though. You want to make sure that you don't end up screwing up the thing that you just solved. So since I made this equal to 1, I don't want to really do anything that messes up this first thing being 1 anymore. Okay? So I'm going to try to not really modify stuff here unless it doesn't mess up what I've already like worked on. Like you don't want to like start screwing up the stuff that you already fixed. So yeah, let's see. Yeah, so let's try to take this one and subtract it and put it in this one. So let's do row 2 minus row 3, and then let's have that go to row 2. All right? So, again, from before, now I'm going to take this row, subtracting from this row. So this minus this is going to get me 0. This minus this is going to get me -2. This minus this is going to get me -1. This minus this is going to get me 2. All right? And now the last step is to get this thing into the last step for the first column is to make this thing equal to a 0, right? And so now what I can do is I can say, okay, let's do row 3 minus row 1 and have that go to row 3. Okay? So now I'm going to do this minus this. All right? So that's going to be 1 minus 1, which is going to be 0. 5 minus 3, that's going to be 2. 2 minus 2, that's going to be 0. And then -1 minus 1, which would be -2. Okay, cool. All right. So we got our 1, 0, 0. That's nice. All right. Let's try to make this equal to 0. Uh-oh, this is kind of tricky. I've actually got y in the last row. Yeah, you're actually right. Oh, so actually, yeah. Let's make our life simple here. You can always interchange rows. I like that, Jeff. I'm just gonna swap these. That makes my life kind of easy, right? Let's swap this one with this one. Okay, so this you can always swap the orders of rows, which is fine. Do you have to write the step? You probably should. Okay. So now I need this to cancel out this. So this is where it's going to get a little bit tricky, right? So I'm going to have to say, okay, let me take 3/2 of the new row 3, and let me add it to row 1, and then have that go to row 1. Okay? Oh, I fucked up. Oh, no. Okay. So first of all, 3... I usually have to write this down for myself. So I know that's 0, negative 3/2. No, sorry. It's going to be negative 3, because it's 3/2 times that. Negative 3/2, and then that's going to be also... Oh, not negative 3. Yeah, negative 3/2. And then 3/2 times this is going to just be 3. So that's what my new thing is for this. And then I'm going to add it to this. And so let's see what we get. So this is going to change. So 0 adding to 1, we're going to keep the 1. Negative 3 adding to 3, that's going to become 0. Let's use a different color for this. So 1, 0. Negative 3/2 plus 2 is going to be 1/2. And then 3, sorry, this needs to be negative 2. 3 plus 1 is going to be 4. Okay. Cool. All right. Now for this one, I want this to be 0, 1, 0, right? So what I'm going to do is I'm going to say row 2 divided by 2 implies row 2. So now we're just going to divide this thing by 2, which is fine. So now that's going to become 0, 1, 0, negative 1. Yeah, multiply by 1/2. That's totally cool. You can say that too. Okay. Now I need to get rid of this one. So I'm going to say 2 times row 2 plus row 3 goes to row 3. Because again, we're doing the snake, right? Doing this. So that's going to be... You can see how it's very easy to make mistakes here. So 2 times 1 is 2. 2 minus 2, that is 0. That is still negative 1. And then negative 2 plus 2, that is 0. Okay, cool. Oh, we're like almost done here. Oh, did you figure it out? Yeah, you could also do... What are you saying multiply by negative 1? Oh, yeah. Instead of dividing by negative 1. Row 3. Yeah, we're going to get to that. Technically, I should go solve this one first before I mess with this. Because again, I mean, this is the order. You're supposed to do it like this. So, you're right. I could just to do it because it's right there. But you should do it. But what I'm going to say is, okay, so now 1/2 of row 3 plus row 1 implies row 1. So now this is going to go away. This 4 stays the same because it's just 0. Cool. And then, yes, your last step is negative 1 times row 3 gets you row 3. This goes away. Goodbye. And you're left with, right, z equals 0, y equals -1, x is equal to 4. Supposedly. Oh, Pongalia, I gotta go through your solution here. Jesus, that sounds fun. The other way to do this, if you want to check your answer, I don't know if you get like a TI-84, but you can literally just like go into this. So if you do second matrix right here, go to edit. We need this to be a 3x4, and just start plugging the numbers in. Or what were our original numbers? So 2, 6, 3, 2, 1, 3, 1, 1, 1, 5, 2, -1. You don't get to use a calculator? I'm going to show you how to do it, just so you can always check. It's very easy. So then you go second quit, second matrix, go to math, do RREF. RREF stands for row reduced echelon form. That's what we basically did. We converted this into row reduced echelon form. Hit enter, and there you get 4, -1, 0. Is that what we had? Yeah, look, 4, -1, 0. Nice, good job.
Well done! Well done!
Nice. Kind of time consuming, but it's okay. Again, just follow the strat there of doing the snake. You'll figure it out. Here, I'll give you the screenshot of it so you can look at it. It's very big and scary there. But yeah, you're very welcome, dude. Nice. All right, here, let me leave you through Point Gallia. So the key idea is that most slices, 3n minus 2 and 3n and 3n, overlap. Ooh, I do like that. Oh, you're so right. Uh-huh. Slices ending in 3n minus 1. Okay, very cool. The contribution of slices containing 3n is dominated by the 3 sign sum, where each slice... Oh, okay. Mod 3. This is very cool. Here, I'm gonna copy all your text here because I just want to save you. I want to save your chat. You took a while to write this. Let me put that somewhere in. I'm gonna put it in here. Okay, cool. All right, yeah. That was a unique question we were doing earlier. It was a Waterloo math competition question. Or go away, Olaf. If any of you guys, any of you math aficionados want to do it, it has to do something with Geimir numbers. Again, if you found us just on Twitch so far, please feel free to join our Discord. The link's there, and then it's also here it gets spammed in the chat all the time. But what we have students do is they go through and they submit screenshots of their questions on our Discord, and we go through them. So if you ever want to like look through and see what students are asking, or you want to submit your own question, you can do so right here. It's pretty cool. And then also we have a huge collection of math streamers who also do free help for, students, middle school through high school, but also do really high level, like algebraic topology, whatever, complex analysis. Like if you like math for fun, which I think Poingalis, it looks like you do, like you enjoy high level math. I do too. I'm just not the best at it. My main specialty is like middle school, high school, and like up to Diffie Q in terms of teaching it. But there are some awesome other math streamers. I think Math Major just joined us. So yeah. That's all the other streamers on Twitch that stream math stuff. Some of them do homework help sessions. Some of them just do like abstract algebra courses where they just discuss stuff. I don't know. It's super cool. And then if you ever want the calendar, that is the calendar of the events and when they're happening. So it looks like our next event is going to be with Zach at 6:30. So be sure to give him a follow so that you can go see what's up with him. let me see. I need to finish up some work for, and we're out of questions today. I don't have any more questions in the stream, but I need to finish up some work for my online textbook startup that's due tomorrow. So I think I'm gonna cut it here at 2 hours, and we'll end the stream. Okay, cool. All right. Thank you everyone for coming out to office hours today.
That's dope.
Really appreciate all you guys finding us, and everyone who asked questions to get help with their classes. Please feel free to come by again. Tomorrow we're going to be streaming an hour later, so that's 5 p.m. Pacific, 7 p.m. Central, 8 p.m. Eastern. Come on by, ask whatever questions, maybe discuss fun math stuff with us. And yeah, also go make sure you go follow all those other awesome math streamers. Friends of ours, they're great. I love all of them. We've built a really fun, cool community on Discord and Twitch. Also, if you know, I had a meeting with someone today who wants to give back, wants to help teach students and whatnot, and is running into issues with the public school system. There's too much red tape. You know, she can't actually help people. And I was like, you should get into streaming. Like, they haven't banned us from helping kids on Twitch, so might as well do it. Report cards, yes, Sora, you do get credit for report cards. Yeah, go do it. You do. Let me see. Who am I following? Who can we raid today? Merryweather's on. What is Is Merryweather doing stuff? Oh, he's doing electrostatics? Okay, cool. Actually, you know who this would be very important for? Who was on here a stream earlier? Mofed or something? He said he wanted to get into electrical engineering. So yeah, okay, let me make sure he's not talking about hag maxing.
Lots of options. How do you get him to marry you?
God damn. He's talking about fucking hag maxing.
It's like this. It's like this, Femvox. Think about this, Femvox. A lot of people.
Anyways, all right, let me see who we can go raid. I love Merryweather, but sometimes Merryweather goes a little off topic, and I feel a little bad sending kids into their rants. Who's on? Dinosaurs? Yeah, let's go talk dinosaurs. Yeah. Go say hi to Paleontology for me. He's a really cool guy. He's a paleontologist, and he talks about dinosaurs, and so you can learn some cool history about that. Otherwise, in 20 minutes, Zach is going to be streaming. Go check out his stream, and tell him I said hi. All right. Anyways, have a great rest of your Tuesday. We will see you guys tomorrow. Peace out.